Okay, good morning. My study was on the stability of productivity and food quality traits of Fuji apples on different rootstocks. So this rootstock trial was established over three locations in South Africa. Two were in Grabo, which is Oak Valley Estate, and Breevlei, and then one was in the Eastern Cape region, which was Langkloof. So I'll be presenting mainly on the dwarfing apple rootstock genotypes because we did both dwarfing apple rootstocks as well as vigorous rootstocks. So in this trial, we had 10 different rootstocks, which also included new rootstock and interstem combinations. So I'll just be highlighting some of the key findings of this trial. So we used different stability analysis that we found, and one of those was the multi-trait stability index, which compares a genotype to a specific ideotype where you actually input how you want an ideal genotype, and in this case, a rootstock, to perform. And in this trial, for this index, we used cumulative yield efficiency, yield, and yield efficiency. So rootstocks which had a lower multi-trait stability index, which can be seen by the values on the left, were better and therefore more stable and highly productive. And these values increase from the outside to the inside of the circle. The red line represents a cutoff. So genotypes that are selected are those with a lower value and are outside the cutoff point. So the genotypes which were selected, or the rootstocks, were G778 with M9 EMLA as the interstem, as well as MM109 222 by this index. The least stable and least productive genotypes were M793, which had the highest MTSI value, as well as M9 EMLA. Looking at the weighted absolute of average scores and the nominal yield plot. So this plot is divided into 4 quadrants with your stability on your Y and your cumulative yield on the X-axis. Higher values represent less stable and lower values are higher stability. So from this, we see that M9 EMLA and M793 222 were the least stable and least productive in terms of cumulative yield, which actually agrees with the MTSI that we just saw. G222 was found to have high cumulative yield but lacked stability. And then just jumping to quadrant 4, the most stable and highly productive genotypes were M7 EMLA, G7789 with M9 EMLA, and also with 222 as the interstem. Looking at the nominal yield plot, we see that G778 and M9 had the highest cumulative yield across all 3 sites, which was Breevlei, Aldewater, and Oak Valley. And we also see that G222 was highly unstable, which can be seen by the gradient of that line. And on to the next one. Based on cumulative yield with same plots, we see that in this case, M793 with 222 as well as with M9 EMLA were the least stable and least productive. M9 EMLA had high cumulative yield but lacked stability. G778 with M9 EMLA and 222 as interstems was highly productive and highly stable. G222 in terms of cumulative yield was actually stable and highly productive. M9 NIC29 was also highly productive and had high stability. Looking at the nominal yield plot, we actually see the large gradient of M9, which actually represents its instability. And we see that G7789 also had high cumulative yield efficiency across all 3 sites, Oak Valley, Aldewater, and Breevlei. We also find that for both cumulative yield and cumulative yield efficiency, we had multiple crossover interactions, and this will mean that selection should be environmentally specific. So in such a case, for cumulative yield, for example, a grower might want to select M9 EMLA over G7789 M9 at Oak Valley because it had a higher yield in cumulative yield efficiency at this site, whereas another grower at Breevlei will actually select G77 M9 because of its high yield. This also represents that some genotypes had narrow adaptability and others had wide adaptability. So in conclusion, using the 3 different stability methods that I've just shown, G7789 was selected by the MTSI and was selected based on cumulative yield by the WASP biplot and the nominal yield plot. Also, we see that G7782 222 had high cumulative yield and cumulative yield efficiency. M7 EMLA was selected based on cumulative yield. G222 in terms of cumulative yield was highly responsive, and therefore this limits its adaptability and selection across a wide range of sites. And in terms of cumulative yield efficiency, M9 Emler was highly responsive. And we also find that Helderwater and Oak Valley, although they're at different geographical locations, they formed a mega environment, so most genotypes or rootstocks perform similarly, and this could be due to management strategies, as that these two, at both sites, trees were trained according to the SOLEC system. And acknowledgements to these individuals as well as organizations. Thank you.